All right. So we're talking today about linear systems. So these linear systems, we kind of touched on them in the previous topic because we were looking at graphing multiple equations and seeing where they intersect. So in today's lesson, the first example we're looking at solving this system, if I try to graph this, and we're looking at this graph, we can't really say exactly where they intersect, okay? Because it's between 3 and 4 for the x, and it's between 0 and -1 for the y value, but we need to know exactly where they cross. And if we don't have a graphing utility with us, we want to be able to solve it algebraically. We have substitution as a method and elimination as another method. So looking at substitution as one of our methods. When you're doing substitution, right, we want to pick one of these equations and we're going to solve it for either variable. You can choose x, you can choose y. A lot of times looking at it, you'll decide which one's easier to solve for. So that'll be the first step that I do here. So looking at these two equations, would it be easier to solve for x or y?
Y.
Well, I would say there's no coefficient by the x. Right? If I wanted to solve these for x, all I would have to do is add 2y or subtract 2y from the equation. So looking at these two, I would say they're easier to solve for x. So if I solve one of those for x, or you could solve both of them for x. If I solve that first one for x, x plus 2y equals 3. To solve for x means I want x by itself on one side of the equation. So to get rid of the 2y, I'm going to subtract it from both sides. And that gets me my first equation is x equals 3 minus 2y. Now that I have x equals 3 minus 2y, okay, from the first equation there, call it equation A. Okay, so this is A rewritten. I can plug it in to equation B for x. So if x is 3 minus 2y, then I can use 3 minus 2y in place of any x I see. So using my second equation, I'm going to plug this in for x. So if I replace x in that second equation with 3 minus 2y, I get 3 minus 2y minus 2y equals 4. So see how that is the second equation, but instead of x, I replaced it with another what x is equal to. So I can plug in 3 minus 2y. Now, if I only have one variable, I can solve for that variable. So I can get rid of the parentheses. There's nothing to distribute there. I just put them in to show that's what I was substituting in for place of x. So if I combine like terms, I have these two y's can go together. So -2 minus 2y is going to give me 3 minus 4y equals 4. I need to solve for y, so I'm going to subtract 3 from both sides. So I end up with -4y equals 4 minus 3 is 1. And the last step to get y by itself is divide both sides by -4. And I find that y is equal to 1 divided by -4. You can just say -0.4. Or you could say -0.25. But that's what y is. Now here, before, when we were looking at setting equations equal to each other on the coordinate plane, we were only interested in the x coordinate. Okay? Because the equations we were looking at only had an x in it. But here, we have an x and a y. Okay? I need to know both of those coordinate points. Once you've found one of them, right? So looking back through the steps, the first step we did, we solved for x. The second step, we replaced the variable in the second equation with what we found x to be. Then we solved for y. Right? So I have one of my variables. If I know one of the variables and I want to find the other, what can I do to find the other variable?
Plug in y.
Plug in y. And it's convenient that over here I've already written a formula for what x is equal to. Okay? So you can plug this y back into either of these equations, or I would use the one that I've already solved for x. Now I just have to plug y into that and evaluate. So after I find that y is equal to -1/4, I'm going to plug that in for y to find out what x is. Because in solving a system, okay, I should have the answer is the coordinate point where they meet. So I already know the y is -1/4, which agrees with my graph. That looks like a -1/4 value of y. So if I plug in 1/4 there, I'm going to get x equals 3 minus 2 times -1/4. And I can turn this into a fraction if it makes it easier, putting it over 1. You can always turn a number into a fraction by putting it over 1. And then when you're multiplying fractions, you're just multiplying across. So this is 3, -2 times -1
2.
would be 2, over 1 times 4, which is 4.
4
Okay? So 3 plus 2/4, or,
is 3 quarters.
Right.
3 half.
yeah, 2/4 is 1/2. So this is 3 1/2. Right? So you could write this 3.5. If you want to write it as a decimal or as a fraction, you could say, that's the same thing as saying 7/2. Right? If you added those as fractions, it would reduce to 7/2. So as fractions or as decimals, but that's the process of solving by substitution. You have to find out what one of the variables is. Doesn't matter which one. Usually we look at the equation and decide which would be the easier to solve for. If it doesn't have a coefficient in front of it, I would say that's the variable you want to solve for. Once you've got a definition for it, you plug it into the second equation. After you've substituted in, there should only be one variable left. You shouldn't have an x and a y after you did the substitute step. You can solve for one of the variables, but remember, you need both x and y. Okay, so if I wanted to go through this step, right, going through this one,
Pick the top one.
pick the top equation, and what variable would I want to solve for?
Y.
Right, I agree with that because this is the only variable that doesn't have a coefficient, which means I don't have to divide by anything. I just have to subtract 2x from both sides. So if I'm going to call this equation A and equation B. So taking equation A, I'm going to solve for x. I'm sorry, y.
So y equals -1 minus 2x.
Exactly. I'm going to subtract 2x from both sides. and then I'm left with y equals -1 minus 2x. And now that I know what y is,
You're gonna plug it back in.
and what equation do I want to plug it back into?
The first one. I mean, the second one.
The second one. I got it from the first one, right? If I plug it back into the first one, I would end up with like a true statement for x. So I'm going to plug this in to b for y. So for equation b, I have 5 times -1 minus 2x. Okay, so there you want to use the parentheses because you have to distribute that 5 to everything in the parentheses. So I replaced the y with what we found y equal to be using the first equation. Now I just have to solve this. 5 times -1.
-1.
5 times -2.
-1.
Okay, and then the x with it. Minus 6x equals 7.
Combine like terms.
We have some like terms to combine with this 10x.
So -5 minus -7.
So I still have -5. -10 minus 6 is going to give me -16x equals 7. I'm going to have to add 5 to both sides. And we get -16x equals 12. The last step is to divide both sides
By -16.
by -16. So I get x is equal to -12/16, which, if I simplify that, what's a common factor 12 and 16 have in common?
2.
2 or 4. Right? If you took out 2, you would just have to take out 2 again.
Right, so 4.
So yes, 12 over 16
3/4.
is the same as 3/4 times 4 over 4, so that you can reduce out the 4. So you get x is -3/4. So x is -3/4 is one of my answers. What else do I need to find?
Y.
Still need to find y. How can I do that now that I know what x is?
Plug in X.
Plug in x. And the easiest equation to do that with is the one I already have solved for y. So yep, I'm going to take this x and I'm going to plug it in right there. So I have y equals -1 minus 2 times -3/4. Which again, if you have a whole number times a fraction, you can make them both fractions just by putting the whole number over 1. So yeah, the -1 is still there. -2 times -3
-6. I mean +6.
is going to give you a +6 over 4.
And then -1.
Remember, if I want to make that a fraction, I can put it over 1. If I want to add fractions or subtract fractions, what do you need to have with them? What needs to match on the fractions? You need to have the common denominator to add fractions, right? So, if I want to make this -1 over 1 to the denominator of 4, then you can multiply the top and bottom by 4, right? So -1 over 1 is the same thing as saying -4 over 4, right? Anything over itself is still 1, plus 6/4. So -4 plus 6,
2.
and then over 4. 2 over 4 is just the same as
So it'd be -0.5 or 1.
positive. 1/2. Because -1 plus 6/4, 6/4 is 1.5.
Oh, never mind.
So -1 plus 1.5 is positive.
I just took my plus, my negative sign for a plus sign.
Right? Also accept the decimal. Okay, -0.75 and 0.5. Either are acceptable. Okay. So now looking at solving a system of linear inequalities. Right? This is going back to graphing. With graphing linear inequalities, it's the same thing as graphing the line, right? As if it were an equal sign. But then you also, the extra step is determining what side of the line you want, because when we're saying something greater or less than, talking about is it above or below the line on the graph. So if we want to solve a system of linear inequalities, the steps are we have to solve it for y, right? We want to get it in slope-intercept form so we can plot the intercept, the slope. So we solve it for y, so we get it in slope-intercept form, and then we just graph them all on the same coordinate plane. So if I want to solve these for y, the first, or this bottom green one, is already solved for y. The middle one, if I want to solve for y, what do I have to do?
Divide by 10.
For the middle blue one. If I want to get y by itself, I need to minus the x from both sides. Okay? So for that blue one, if I subtract x from both sides, I get y is less than or equal to 20 minus x. Or you could say -x plus 20 if you prefer seeing it in slope-intercept form. Or these are the same thing. You can flip-flop it, it's still equal. And then the top one, if I want to solve that one for y, I have that extra step. First I have to subtract 20x from both sides, then I also have to divide by that coefficient. So first, I'll subtract 20x from both sides. So I get 10y is greater than or equal to 200 minus 20x, and then divide both sides by 10. And remember, when you divide by 10, everything on the left is being divided by 10, everything on the right is being divided by 10. And remember, if I'm multiplying or dividing by a negative, what do we do with that inequality sign?
You flip it.
That's right, flip it. So kind of a throwback to Algebra 1. If you have an inequality sign and you're solving inequalities, you flip it if you multiply or divide by a negative. So here we're dividing by a positive, it's fine. We don't have to do anything special. We're left with y is greater than or equal to 200 divided by 10. Just reduce one of those zeros on it. And then 20 divided by 10. Or you could write that as -2x plus 20. Again, if you prefer in slope-intercept form. So I have three equations I'm plotting. That one, this one, and this one, or those two. Right? So graphing the line y is greater than or equal to 5. So if it was just y equals 5, what does a constant function look like again? Just a straight line. Right? So y is greater than or equal to 5 is still the straight line at 5, just like y equals 5 would be. But since we're saying y is greater than or equal to 5, I would want everything above that line would satisfy this equation by itself, right? If I was up here at 6, that would make that inequality true. If I was up here at 10, 10 is greater than 5. That makes that inequality true. So that's the first line, y is greater than or equal to 5. The second line, y is less than or equal to 20 minus x. So there, my intercept is what? If it's in this form, it's easier to see. What's your intercept? It's 20. Okay? So the number by itself in the equation of a line is your intercept. So on the y-axis, I have a point here at 20. And then its slope is a coefficient of -1. So I'm going down 1 to the right 1 to plot that line. And then, because I want y less than or equal to 20 minus x, I want everything below that line. So first you plot the intercept and the slope, just like graphing all those times before. He said it's because it's less than my line, I want everything below it. The other line, 20 minus 2x, same intercept of 20, now it has a slope of -2, so it's going down 2 to the right one, down 2 to the right one, down 2 to the right one. So plot the intercept, go with the slope. This line is y is greater than my line. If y is greater than my line, that means I want everything above the line. So everything basically kind of looks like to the right, but it's actually above the line. So everything above that line is being shaded. And if you put all three of those together, the shading would overlap only in this section. Okay? So the idea behind solving a system of inequalities is you graph them all, and then you're determining what region is being shaded by all three of them. If this one's above, this one's below, and this one's above, then this shaded region here is the only region that satisfies all three of those equations at the same time. And my answers could be any point that's in this shaded region. So if I pick 10,6 is a point in that shaded region, that would work for all three of those equations. It would make all three of those equations true. Right? The same with any other point in that region. As long as it's in the shaded region, it would be an x and a y that would make all three of those inequalities true. Okay, so trying this one. I have two of these that I have to solve for y. What do I have to do to the first one to solve for y? I have to subtract 2x. So if I subtract 2x from both sides, that top equation becomes y is less than or equal to, you could say 14 minus 2x, or you could say negative 2x plus 14. Either way. In the second equation, I have to subtract x, and I would get 2y is less than or equal to 10 minus x, or negative x plus 10. And then I also have to divide by that coefficient in front of y. So I'm going to divide everything by 2. That's going to make my second equation y is less than or equal to negative 1/2 x plus 5. And so those are my three equations to plot, or I'm sorry, 4 equations. So if I start with x is greater than or equal to 0, if you see x is equal to something, right, we said y equal to something was a straight horizontal line.
So it's a vertical.
So x equal to something is a vertical line. So x equal to 0, or would be a line vertical when x is 0. Okay? And because I'm greater than or equal to 0, I would shade everything to the right side. So I'm just going to put an arrow there indicating what direction I would shade. I don't want to shade everything yet. I only want to shade where they all overlap. So then the equation below that, y is greater than or equal to 0. So that would be a flat line when y is 0. And am I shading, would I shade above or below that, looking at my inequality? Above, right? If y is greater than 0, that means I would shade everything above that line. Okay, so now those two conditions limit me to this first quadrant. Now I have to plot my last two. So I have an intercept at 14 and a slope of -2. So if I'm plotting that, I have an intercept at 14. I'm going down 2 to the right one. Down 2 to the right one, down 2 to the right one. And I get a line that looks something like this. And because y is less than that line, am I shading above or below it?
Below.
Below. So I would be shading everything below the line. Okay, so now I'm only looking at this part is where all three of them overlap, but I have one more equation to graph. -1/2 x plus 5. That's going to put my intercept at 5, and the slope of -1/2 would be down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I'm going to get a graph that looks something like this. And because it's y is less than, am I shading above or below the line?
Below.
Below. So then the only part of this graph where all three of those overlap, so I was looking at, it overlaps to the right of this, underneath this, above this region right here, I would shade. That would be the only region where I could pick any point in that region, and all three of those inequalities would be true with whatever I pick. All right. So, the other method of solving a system, elimination. So here, this is their first 3-variable system that you guys have probably seen. And we want to find a solution to that system. So if I have 3 variables, my answer is going to be 3 coordinates, an x and a y and a z coordinate. To solve this, we're going to add together equations to cancel out variables. So, if I'm looking at these, I see, if I'm looking at this first and second equation, I see that if I just added them as they are, a -z plus a z is going to get rid of that, right? It's going to cancel it out. And then a -x plus an x would cancel each other out. So, in solving this system, I'm going to begin by adding, I'm going to call these A, B, and C. I'm going to begin this problem by adding together A and B. So if I put them together, 2x plus y minus z equals -10 plus negative x plus 2y plus z equals 3.
So then you would combine the 2 minus the x.
Right, so 2x minus x is going to give me
1.
just 1x. And then y plus 2y is going to give me what? 3y. Z, negative z plus z
Cancels.
cancels, and then negative 10 plus 3 gives me negative 7. Right, so now I have those two equations where I cancel them out.
What would you take?
So-
Plus 3y equals negative 7 and add that to c.
Well, so now I have a new equation in my system. Right? And so my new, if I am replacing A and B, I'm adding them together. So my new system is like this is replacing equation A. Right? So this would be like my new equation A, x plus 3y equals negative 7. And then after that step, I want to continue canceling out my variables. Okay? So I could add together equation B and C, right? And I would cancel out my x's. But I also need to cancel out, so the equation that I have, I got rid of z. So I need to come up with an equation that would cancel out my other z.
Minus 3.
Right? So I need, so if I want to make this, or if I want to get rid of the z between these two equations, right? I got rid of the z between these two equations. This would have to have like a multiple of negative 3 in front of it, right? I can multiply that entire equation by negative 3, and it'll still be the same equation. So this is my new top equation. I'm going to multiply this one by negative 3. And my new equation, negative 3 times negative x, is going to be 3x. Negative 3 times 2y is going to give me negative 6y. Negative 3 times z is negative 3z. And then 3 times negative 3 is negative 9. And then I still have my bottom equation, x plus 2y plus 3z equals 13. Right, so that's my new system. Now I have that the second and third cancel out the z together. So if I add those two equations, so adding my second and third equation together, I have 4x minus 4y equals 4. Okay.
Can't you all divide by 4?
So yes, I could divide everything here by 4.
What if you do x minus y equals
Yeah.
0?
Yeah. And you could simplify that way. You could say everything divided by 4 gives me x minus y equals 1. So now my new set of equations, this was still the equation that I had. So I have x plus 3y equals negative 7. Then I have that other equation, x minus y equals 1. And I still have that third one, right? So when you put together an equation, it just replaces the existing one you had. I still have that last equation, x plus 2y plus 3z equals 13. Now, between these first two equations, I can get rid of another variable and I'll have one left. Right, I can get rid of the x. So, if I put them together as they are, they're not going to cancel. One of them needs to be a negative x. It doesn't matter which one I multiply to change the sign. I'm going to multiply the second one by -1. Just to make it negative x plus y equals -1 when I put it together. So this is going to be x plus 3y equals -7 plus negative x plus y equals -1. So adding those two equations together, the x's cancel out. 3y plus y is 4y equals -8. Divide both sides by 4, and you get x is -2. Sorry, y is -2. All right. Now I just have to go back in. Once you found one of those variables, now I'm going to go back in and do some to replace my variable y with -2. So if I say y is -2, that's one of my answers. How can I find my x? Which equation do I want to use to find an x? We could use any of these, really, right? This one looks pretty easy. The x minus y equals 1. I can use that equation to solve for x. So if I plug in x is -2 into any of these equations where I just have two variables, like I could even plug it into this one. So I'll plug it in here. I have x minus -2 equals 1. Minus a negative becomes x plus 2 equals 1. Minus 2 from both sides, I get x equals -1. So that's my second answer. I still need to find out what z is, though. So I can go to any of the equations that have 3 of the variables in them and plug in the 2 that I do know. So if I go to this last equation that I was left with, I'm going to plug in -1 for x and -2 for y. When I do that, it's going to become -x, oops, sorry, -1 plus 2 times -2 plus 3z equals 13. So 2 times -2 is -4. -1 minus 4, I can combine those like terms and get -5 plus 3z equals 13. Add 5 to both sides, and I get 3z equals 18. Divide both sides by 3, and you get z is 6. Okay, so that's solving a system of 3 equations. The idea is you want to add together equations until you get rid of 2 variables, and then you can start plugging back in once you've found what one of the variables is. Right, so my final answer, I would write this as a coordinate point. It'd be -1, -2, 6 as my final answer. And this very last section on writing a system as a matrix. So in the next section, we're going to learn how to use calculators to solve those systems of equations. And the calculators use what's called matrix operations to solve them. So a matrix is just an array of numbers where the numbers represent the coefficients of your variables. And to write a matrix, they first have to be in standard form, meaning something times x plus something times y equals a constant. Okay, that's standard form. Once an equation is written in standard form, you write the matrix just by pulling the numbers in the equation. Right? So if I rewrote the given into standard form, it would be 2x plus 3y equals 1, and 4x minus 2y equals 10. To write that as a matrix,
Is a headache.
it would be 2 is the coefficient of x in the first equation, 4 is the coefficient of x in the second, 3 is the coefficient of y, -2 is the coefficient of y, and then the 1 and 10, those go in the last column, what's called an augmented matrix. Okay, so there's a coefficient matrix where you just see like the coefficients. An augmented matrix shows them and what it equals to. And the dimensions of a matrix are rows by columns. So this would be a 2 by 3 matrix, because it's 2 rows and 3 columns. And if you don't see a variable in the equation, the coefficient is 0. Okay, so you want to take that note on it. Oh, and one other note that I forgot to touch on up here.
No solution.
Yeah, if a system has no solutions, then it is called an inconsistent system. Okay, if it has no solutions, it's an inconsistent system. So no solutions would be like if you solved it.
Equals 0.
Yeah, you got like 2 equals 1, right? Then that system would be no solutions. We call it inconsistent. Okay.